All right. Hello, chemistry students. Doing another example problem for you here. This is Mr. Kirsten. We're doing from homework 10, problem 26. Determine the Celsius temperature of 2.49 moles of gas contained in a 1-liter vessel at a pressure of 143 kilopascals. So whenever I do a problem, the first thing I do is kind of write down the information that I know from the problem, okay? So determine the Celsius temperature, okay? So temperature is what I want to know, and I'm going to make a note here that it's got to be in Celsius because it's asking for Celsius temperature. And then I'm told the moles, so we're going to use the letter N to represent moles. So I'm going to write that down, 2.49 moles. Contained in a 1-liter vessel. So it looks like the volume's 1.00 liters, okay? And a pressure of 143 kilopascals. So 143 kPa, okay? Okay, and again, temperature is what I want to know. Okay, which gas law am I going to use? Okay, now you'll notice a couple things here. All of the gas laws on here so far have like 2 volumes and 2 pressures. All right, here we're only given 1, but we are given moles. Okay, so if you are only given 1 variable and you need to use moles, you're going to want to use the ideal gas law, okay? And the ideal gas law is not on your equation sheet here, but there is some kind of information about it here, and we'll get back to here in just a second. So the ideal gas law is PV equals nRT, and for now we'll just say you kind of got to memorize that, okay? PV equals nRT. Okay, and if I look at this, I've got pressure and volume and moles. I'm looking for temperature, but what's this R thing? Okay, so R is a constant, but there's 3 values of R here. So you might be asking, which value of R do I use? Okay, well, notice all of these talk about liters, moles, and Kelvin, but the unit that's different on here is ATM, kPa, and mmHg. Well, those are units of pressure. Okay, so you're going to use the R value that corresponds to the pressure unit you're using. So I'm going to come over here. I notice that the pressure unit here is in kPa. So I want to use the R value that is listed in kPa. So here's kPa. So my value of R is going to be 8.314. So I'm going to write that down here. R for this problem is going to be 8.314. Okay. So let's, I now know everything I need to solve this problem. So let's start plugging in some things. So P here is 143 times the volume, which is 1.00, equals my moles, which is 2.49. Okay, that's a 1 there. Times R, which is 8.314. Times my temperature, and my temperature is kind of like my X, all right? So this is what I want to solve for here, all right? Okay, so what I like to do is do a little algebra here. I'm going to divide on both sides by 2.49. Okay, divide on each side by 2.49. That cancels this out. And I'm going to divide on each side by 8.314. Okay, and that cancels this out, and I get T all over here by myself, right? Okay, and then I'm going to grab my calculator here and type this in. So this is 143 times 1 divided by 2.49 divided by 8.314, and I get a temperature of let's call it 6.91 if I round to 2 decimal points, okay? Now remember, we're not quite done yet here. Whenever you plug temperature into an equation, it's got to be in Kelvin. So this temperature here is actually in Kelvin, but the question is asking for the temperature in Celsius, right? So by now, you probably basically just have memorized that if you want Celsius, you're going to take your Kelvin temperature and subtract 273, right? So I'm going to do that here. So this is 6.91 minus 273, right? And if I type that in my calculator, I get that the degrees Celsius is negative 266.09 degrees Celsius. And there you go. Okay, there is your answer. All right. Okay, good job, chemistry students. Keep up the good work.